Advent of Code 2024, Day 7. We have a list of equations. For each equation, we know the operands and the target value, but we don't know the operations. We only know that every operation can be either addition or multiplication, and that they are executed from left to right, ignoring the usual precedence rules. We want to find out which equations can be true, given the right choice of operators, and sum up their target values. A simple strategy is to try every possible combination of operators. If we have n operands, then there are 2 to the n-1 such combinations. This takes around 10 seconds on my machine. A slightly smarter way is to view the problem as a graph traversal. Every node is identified by its current value as well as its index along the operand list and has 2 children, one for addition and one for multiplication. We can traverse this graph using either breadth or depth first search. We can prune the tree once we have overshot the target value, because none of the operations can decrease the value. We terminate as soon as we find a node that has used all of the operands and whose value matches the target. This works much faster, but will still be a bit slow for part 2. This is because part 2 introduces one more operation, concatenation. What seems like an insignificant change at first will increase the state space to 3 to the n-1. So if our equation has 9 operands, it means that we go from 511 states to almost 20,000 states. The DFS traversal will actually run in about 4 seconds for part 2, but we're not satisfied with that. Our current solution feels a bit like throwing spaghetti at a wall and seeing what sticks. There's no way for us to decide early on whether a path is promising. So, what if we went in reverse? If the last operator were a plus, we know that the remaining operations have to produce our target value, minus the last value. But determining whether that is possible is simply another instance of the same problem we've been trying to solve. For multiplication, things are even better. If we find that the target value is not divisible by the last value, we can completely dismiss that branch. Same for concatenation. In this way, we work ourselves backwards until there's just one operand, which is either equal to the target value or not. We can implement this using a recursive function. To concatenate 2 integers, we need to figure out how many digits the second one has. We can do that by counting how many times we can divide it by 10 until it becomes 0. The final solution runs in under 1/10 of a second for both parts.